It's 10:20, so I know you have more questions. We're going to take a 15-minute break. You have an opportunity to ask Amy questions now, and then in the breakout sessions this afternoon. So we'll come back here. I'm really pleased to introduce Mary Manning. I didn't get to introduce her before because we weren't sure she was going to be here. Mary is the regional ecologist for the Forest Service, and she's been working all over Montana and into Idaho and adjacent states. She's working at the national level on the Riparian Core Protocol, so working on interagency, multiple interagency efforts to come up with some sort of monitoring objectives, methods, and an analytic interpretation. So I'm really happy that she agreed to be here today, and is going to give us some examples of what she has seen in what is really kind of a long career at this point.
Yeah.
And I think will be really instructive for all of us in terms of responses to management actions.
Thank you. Yeah, it's been long, all right.
Yeah.
I'm tired. Linda and I, what's wrong with us? But we have so much fun. We just can't, we can't do that. So I need you to watch my time because I have about 4 things I'm going to talk about. And Linda just reminded me too that yes, I worked on the National Riparian Monitoring Core Protocol, and it did get published as a GTR, and I'm not presenting on that today. That was developed with a bunch of folks, but it was developed after I started working on this project with the Beaverhead Deer Lodge and the Custer Gallatin. And Sarah, I want 2 people to stand up. Jessie Salix is my co-presenter, and she is key to much of what we've been doing, and she's going to help me with 2 of the presentations. And then Sarah worked with me. I got to work with Sarah quite a bit on the Custer Gallatin. It was great to see you, and we lost her from the Custer Gallatin, but really wonderful people to work with, and that's part of what makes this job so wonderful. So we're going to talk about, I have a few examples, and this is going to be not a methods presentation, but I need to touch on methods. It's more, what are we looking at and why, and how are we interpreting what we see? So I want you to remember this photo also because I'm going to refer to this. And this is Selway Meadows, for those of you who know southwestern Montana. It's on the way to Reservoir Lake, past Horse Prairie, and we've worked there quite a bit. We've had some fun times, right, Jessie? And we had to laugh at this because that's Jessie there with Udit, and that's how you pronounce it. She's from Amsterdam. Jessie was getting a lot of international folks to come help, and it was a lot of fun over the years to have various people. But we just thought that was such a cute picture. The cows wanting to come in, and we said, nope, you cannot at this time. So some of you may know about Selway Meadows. It's a big deal, but I'm not going to get into it right now. Do I push this, Sarah, next?
Yeah.
Okay, so I'm going to start with this, and then notice, sorry, Sarah, in small letters, also Custer Gallatin. But I've worked for probably 10 or 11 years, longer with the Beaverhead Deer Lodge, but also Custer Gallatin, on a riparian wetland monitoring approach that really looked at those streams, those lower gradient streams, alluvial channels that, where vegetation is critical to armoring the banks and building in function, that are impacted by livestock grazing practices in particular. So we did a lot of masking in GIS ahead of time to develop sort of a probability-based sample of breaches, spatially balanced across watersheds, and then sample those and make inferences. So we wanted it to not be a biased or targeted approach, but it was narrow in focus in terms of our sample population and how we defined it. So these photos are from the Beaverhead Deer Lodge, and I'm going to get into just a little bit the sampling approach. So when we started this, Packfish and Fish developed their biological opinion effectiveness monitoring program, and Mark Coles-Ritchie actually came out in the field with me, gosh, probably 12 or 13 years ago, and the region had been getting PIBO data collected throughout the area where the anadromous fish were, and then it got extended into the inland fisheries. So the infish, we extended our sample east, but we wanted to tie into their approach in terms of what they looked at and sort of how they collected the data. So we took a reach level approach, and I should say I came from the Intermountain region of the Forest Service and worked for Al Windward. So I actually was able to when his riparian complex concept started, we were able to go out and actually do that work. And the green line, I mean, I was so fortunate to get to have firsthand experience with Al in the field and really understand the green line approach that then Herb Kelly and Tim Burton carried forward, of course, through the MIM protocol. So the idea is that we have 42 green line quadrats and 30 cross-section quadrats within what we believe to be, and this is the big issue, you know, the riparian area. Now we know you can either over or under sample depending upon how the stream is moving through the valley, how wide the valley is, if you're bumping up against side slopes. There's all kinds of noise in the system. But we did this knowing that we wanted some sort of a spatially balanced approach. I will say with the core protocol that I worked on, we built upon this effort, and Kate Dwyer and Mark Goldsritchie, along with Dave Barrett and myself, were test driving this years ago in Colorado and comparing how the approach we took, which did not have a green line set of quadrats, compared. And we also used line planners. But I only have a limited time, so I'm going to just try and focus on this. So this is kind of an approach, and it'll come up as I show you some of our results too. So the idea is that I should clarify that we built this in conjunction with the hydrologists so that just like Paivo, the distance, the length of the reach is 22 times bankful. And that was how Paivo was doing it. And I think some of that gets modified. Al had it as at least 363 feet minimum, and hopefully 2 meander scrolls. Those are sort of the general rules. But you scale it to the size of the stream, which could also reflect the size of the watershed that it's draining, whether it's third, first, second. Those are the orders of streams we usually deal with in the Forest Service. So then we do a quadrat-based approach. So we use the 20 by 50 Meyer frame. I'm not going to go into a lot of the details about cover, but we were collecting cover, and that will come out in a bit. So what we collect and how we use it. So we collect cover by species to derive species composition, but that's just one derivative. We get tree density by species and size class. So we want to understand what kind of recruitment's coming in from conifers. Spruce may be okay, lodgepole maybe signaling or drying, you know, just looking at that. And what we did, and this is based upon me working with other riparian folks in the Forest Service, is we bend up our species level data into functional groups so that while maybe there's a lot of noise in whether it's Carex quellis or Carex nebraskaensis, for example, both those species maybe are both back wet, they are high ranked bank stabilizers, they're native. Those are our 3 functional groups. I'll get into more of this later. So I'm going to talk about this more. One of the things we were thinking is, what would a range specialist want? Well, do we have a lot of weeds? So native, non-native. Certainly in terms of the functional groups, when we look at you know, obligate, fac wet, etc., if we're seeing shifts into upland or fac up, that signals something, a change. So those are the sorts of things we're looking at. We have a top 10 list I'll get to, and we look at our ground cover. That's important. And then, again, I mentioned the tree density. So I'm going to jump into some things right away and then show some results. So along the green line, and, you know, Alden talked about it. We've been hearing this, Amy too. You know, this is an area where it's where the water and the vegetation interact. It moves around. It depends on when you're out there. You know, if you're out there during bankful, a lot of times your green line is submerged. But if you have those emergent rooted sedges fingering out into the stream, you know, sometimes it's hard to know where it is. So it's one of those really fuzzy things. A lot of people have problems with it. But ideally what we want is we want to have strong root masses, because in those fine textured, unconsolidated alluvial soils, you know, that's the rebar that holds it together. And I'm going to build upon this in a little bit. So the other thing is that Jesse pointed out, Jesse and I worked really hard on this, and we've been working really hard on our riparian reports, like a lot. And, you know, she pointed out that while what we collect probably is not getting at the bank trampling and shearing quite to the degree that we think maybe we need to. And so, you know, Alden mentioned MIM, and we have a bank alteration protocol that sort of quantifies, does a count of hoof prints along sort of a point step approach. It's not perfect. I would like to do more with it, but it's something the range specialists can do out in the field. But we know that we need to probably work on this. So what we're looking at, these are just a few things I wanted to point out. So one of the big issues I mentioned is non-natives. So here we've got Canada thistle in a drier area, but we also know that Canada thistle will start coming in. That's one that Jesse and I just finished up a report. We want to really call that out because, to me, that's a big deal because, you know, I've seen them just take over huge expanses of riparian. So that, to me, is an important one that I think is useful to managers. The other oh, I didn't want to do that. I just do. I killed it. Go back. Oh, my God. What I was trying to show you, no, we don't want that. How do I go backwards, like this? Okay, so the other one that we aren't really doing a great job on right now, because it's somewhat hard to do, is browse class. So browsing of your shrubs. So what we're collecting right now is cover. And you got to remember that when you start these things out, I actually worked with another ecologist years ago on this, and Mark, close Richie, and I also had to work with the team of specialists on the forest. And if you start piling too much on, as much as I agree with Alden, I agree with you completely. If you're going to take all the trouble to get out there and install it, why short sheet it? You know, it's like crazy. So I would like to have done more to quantify that, because in the Forest Service and our legacy data, we do have browse severity classes that you could, you know, they're just a category, but they still might be useful. So we are looking, and the other thing is bare ground, hoof action. How does that facilitate the spread of a species like Canada thistle? Now, it's highly rhizomatous and aggressive. It could probably get in there anyway, but that may facilitate other things coming in. So we did look at all this. Now I'm going to just, okay, we had to put in some graphs, but I don't have a lot of time. I've got other things to cover, so I'm going to be fast. But you can talk to me in the breakouts. What we wanted to do is graphically display changes, so, or not changes. And I'm saying that because, Alden, I thought about what you said about being statistically significant. We've been working on this with folks, and right now all we can do, because this is 2011, this is all Surveyor Creek, and I want you to remember this because I'm going to tie this together in a second. So 6 years difference, 6 or 7. You can see this is frequency by indicator status. What does frequency mean? So along the green line, there's 42 frames, right? If it occurs in 21 of them, it's 50% frequency. The reason that's important is a reach level sample. I want to know if, as you go along the stream, are you seeing Nebraska sedge or water sedge? Are you seeing beet sedge? Or is it just sporadic little clumps? So where, you know, how is that system holding together? Because that's ultimately what we're trying to do. So we have frequency, and that's derived from our data, but we also have cover. And so one of the things Jesse and I look at a lot is we compare, well, like this species of sedge was in 80% of the 42 frames, but its cover is pretty low. Now, the way we calculate cover is if you have 42 frames and it occurs in 20 of the 42, you still use 42 as the denominator. So 0 values are accounted for. It's not, again, if you are in, say, 10 of the 42, you don't go 10, 10 values divided by 10. Frequency, because what we're doing is these are subsamples within our macro plot. So I wanted to be clear so you guys understand that. So where it occurs, for example, a willow, a lot of times very clumpy. Where it occurs, it might have very high cover, but it may only occur in 10% of the frames. So I just wanted to say that. So what we're trying to do is understand if there's changes. And again, this is quick and it's probably going to drive you crazy, but now what is really cool is we also want to break it down. Okay, we have the functional groups, but who's a member? Who's part of that? So blue is obligate, good guys, and red is fact wet, also good. So, you know, what we don't want are the purple or even the green. But you notice we've got Carex cordless and Geyer's sedge or Geyer's willow, and we're looking at how much of this is blue and red. I mean, visually you could do that. You could say, this is great. Well, shoot, we got some greens in here. But look, these are the top 10, most common. That means you do a list, you rank them by frequency. Who's most common? Well, here, I guess we lost Pinus contorta. We'll talk about that in a second. So again, I'm thinking about the district ranger. I'm thinking about sitting down with the permittee. How do we make this, how does it make sense to folks? So this is dominant. I'm not going to go into this one because I want to jump to this table. Again, think about it. You have these functional groups. Okay, we got a bunch of these guys. That's great. But you're wondering about the membership. So one of the things we did is we do the bar charts. And Jesse and I have gone back and forth. We've had people do this. Does this resonate with you more? Maybe not. Some people like tabular information. So what you have is, I asked her to do it by frequency. Look at this. 80% of those 42 frames is water sedge. That's good. Average cover 12%. Remember, it's average across the 42. And then the next year, 83, 12. No real change. You've got some different crews. Jesse and I have dealt with that. We're dealing with a lot of, you know, species ID issues. It's very interesting. Again, functional groups helps. So now we're going to talk about bank stability. Alden mentioned this. So in Al's 2000 publication, he referenced, I think it was ranking from 1 to 10, how well these species armor banks. Some of you may know I did my master's on root length density. I counted roots. That was my life for 2 years. In meadows up in northwestern Nevada. So I had data on 4 species, Nebraska sedge being one of them, Baltic rush. But these other calls were a little more like, well, I think it's this. So what I've had to do is we have a whole spreadsheet, and for every species, we rank them. And, you know, the gold standard is up here, but it's really tough in between. So you got to remember that if you don't have data for every one of those species, you kind of have a sense. I mean, we all know Kentucky bluegrass just is not cutting it for holding the banks together. We know Nebraska sedge is. So these things are super helpful, and we've seen some very interesting trends. Again, this is frequency. So you're looking at how well those high bank stabilizers are moving through. Not looking great. So it went from 55 to 30. Again, could be some noise in the sample. And then I think, Jesse, do we have? So this is the cover. So this is where it's really interesting, and I'm going to pull it all together in just a second. So look at this. So, oh, no. Okay. So 76 and 59. Okay, so there's something going on. There's a lot of something. This is cover, not frequency, remember. So all the coverage is being made up by the high-ranked stabilizers. Now, check this out. We just got this hot off the press. We've got a gal working with us, Katie Renwick, who's in California, did this for us while she was in California. So, Surveyor Creek. Remember I mentioned Surveyor Creek? There it is. Check it out. Okay, and the yellow is the graminoids. Those guys are workhorses, if they're the good guys. And we want them all over there, because they're the fine rebar that holds all that soil together. But in our case, Surveyor Creek, which has been all the graphics, what's happening is you have a woody component, and you say, well, is that really effective? And we've asked ourselves that. And so, remember I mentioned Selway Meadows, the very first picture you guys saw, the cover, the title slide? Selway is this dude right here. Check it out. It's a graminoid-dominated system. We wanted to know because you know, if we're misleading folks by saying, oh, this is great because guess what? What we have, this is the photo of Surveyor Creek. So yeah, there's sedges, that's awesome. They've been grazed. But it turns out there's a lot of lodgepole in there. And relative to Kentucky bluegrass, this gets back to the rankings, lodgepole can armor the banks, but we know there's windfall. It's really tough. We know through sampling all these systems in the Big Hole and in areas like that, you're going to have lodgepole. They come and go depending upon the seasonality of the water table, but they're there, good or bad. And we have a lot of willows, really great looking willows. So we know that this system is very different than Selway Meadows, very different. And so the point in all of this is that this is something that Jesse needed because it helps us think about our management. Because cows don't eat lodgepole, they eat graminoids usually, right? So we need to be thoughtful on what that means if we are seeing things happening. So again, this is big sedge and water sedge, great. But we also know that it's probably getting favored and that we need to be thinking about how we manage what we have. And I don't know if that makes any sense, but I think I have to move on. Oh, this is nativity. You know, that's just from Plants Database. Good to know. We knew there was Canada thistle in Surveyor Creek. But this gives a sense that, hey, you know what? We're not doing bad. So we want to have some good news too. And then one last on this, and then I'll move quickly. Ground cover is nothing more than, we do point intercept on the corners of the frames. And so it's like a point frame. It's a modified point frame. And so we think this has been valuable. And if nothing else, if we were to compare with other reaches, and we take copious photos and we do a rapid assessment, kind of like a modified PFC with lots of notes, we think this is still important because if we're seeing a lot of bare ground, that's a problem. Here we've got a pretty good component of litter. Okay, now I'm moving quickly. How am I doing? Am I done?
I'm done.
Oh my God,
Really
I can't even believe this.
Go really quickly.
Okay, this is so exciting. I got to tell you this one. Okay, this is down in Big Sheep Creek. Some of you know that off by Dell, right? So this is so awesome. This is the craziest thing. You've got this rare alkalized primrose, Primula alkalina, okay? And the BLM, I'm just going to go fast. The BLM, I'm going to go to this picture first. They were concerned because it's like an S2G something, I don't know. But the thing about this plant is that this is all BLM land here. This is the original BLM crew. This is us years ago in 2006 coming out, and this is me working with Jesse. The deal is that these alkaline sedge meadows, through a lot of hummocking and hoof action, have created a situation where the alkaline primrose numbers are going up while the system is tanking. And I was out with the botanist, he's like, look at this, there's so many alkaline primrose. I said, this is not good. I mean, these systems, and I don't know, Alden, if I talked to you about this when I talked to you on the phone, but these hummocks, it's like a chronosequence. Like, I have pictures where they just collapsed on themselves. And there's nothing left. I mean, there's probably some little redoxymorphic features you could see, but what's happened is when they're just on the cusp of totally, unraveling, then all of a sudden you get these numbers. And so what we did, this is what Jesse did. This is all Jesse. Based on the BLM stuff. We wanted to look at height of the hummock, number of individuals on the side, the top, and the bottom. And I'm not going to talk about the alpine meadow. That's another species we look at. But it's like, and then it was flowering versus vegetative, number of flowers. Very laborious, but that's what these rare plant people do. It's not my thing. But the point is that I really truly believe that somebody needs to get a grad student to work on this because eventually the whole population is going to tank. It's killing the goose that laid the golden egg. And then, okay, Linda, this is all I'm going to say. Okay, I'm also working with this interagency team. Alden mentioned the Natural Riparian Service team. So this is Mark Gonzalez, Steve Smith, and then some folks from BLM, and I'm the Forest Service, the token Forest Service person. But the cool thing is, I just want to focus, we it's a core protocol through their assessment, inventory, and monitoring effort. I have been fortunate enough to get somebody to actually want to do this up in North Idaho, all the way up at Bonners Ferry on the Canada border. I kid you not, they're grazing cows up there, and these peatlands that have rare Drosera, the sundew, and other such things, cotton grass, we are actually sampling up in here, so we've done 3 years worth of data. I'm going really fast. And one of the things we're looking at is, in particular, in these sphagnum-rich fens, what is happening to the sphagnum, what's happening to the peat. And so when I mentioned this, we want to understand, and there has been some work, and Linda knows about this too, Dave Wexman and David Cooper, California. Does peat regenerate? Does sphagnum regenerate? And how do we capture the degree of desiccation and oxidation and the functionality of peat? So that is part of what we're doing in this particular thing. And then I have one more slide. Oh, I wanted to also mention unnatural flow patterns. Alden nailed it. I'm bringing it in again. This is a key part. And so you see that in these photos too. So this is actually a fence line, you can't tell, but we really, really care about unnatural flow patterns, because then you're squeezing the sponge, making it into a pipe. So that's a big deal. And then this is just a placeholder for another conversation. I have a friend in Montana who I go out into these fens with her, Sealy Swan. She's building state and transition diagrams. Alden, this is what I was talking to you about. Steph couldn't come. But she put this together for me. This was done up in Eureka, and then her reference state is more these flow-through and basin fens that she's doing the Sealy Swan. So we can talk about that later. And then all I have left is just a question slide, because I thought it was a pretty picture, and so that's it. So I know there's no time. I tried to go as fast
No,
as
that was
I could.
great. You did go as fast as you could.
I'm exhausted.
There is no time for questions. We're going to move on, but there will be time this afternoon. Mary and Alden will be.
Yeah, we'll be in the, and we really want your input.